Hi guys, welcome to Algorithms Made Easy. In this video, we'll see the question Pacific Atlantic water flow. Given an m cross n matrix of non-negative integers representing the height of each unit cell in the continent, the Pacific Ocean touches the left and the top edge of the matrix and the Atlantic Ocean touches the right and the bottom edges. Water can flow in four directions: up, down, left, right, only from a cell to another one with height equal or lower. Find the list of the grid coordinates where water can flow to both Pacific and Atlantic Ocean. The note attached with this question is that the order of the returned grid coordinate does not matter and both m and n are less than 150. So instead of looking at this example over here, let's see this visually so that we can get a better knowledge about the problem statement and how we are getting these coordinates as our answers. So the main gist of this question is understanding the problem statement itself. If you know the problem statement, it would be much easier for you to implement a solution for that. So for this, I am taking this particular example over here, and as mentioned in the question, the left and the top borders have the Pacific Ocean attached to it, and the right and the bottom border has the Atlantic Ocean near it. And the numbers over here in the cell determines the height of that particular grid or the continent, and we need to find whether from some of these continents the water can flow to both Pacific and Atlantic. Rules for water flowing are that from a particular area the water can flow in four directions: up, down, left and right. But when that can flow to that particular coordinate only if the value of that cell is either same or lower. So now if you consider this 3, according to the rules the water can flow in these four directions, and according to the second rule these 3 are unreachable because these have a height which is greater than the height of this particular cell. So the water from here can only flow in this direction towards 1. Similarly, if you go to 4, the water can flow in all these directions because the heights are either lower or same. And over here we can see that the water is going into Pacific and the water is also going into Atlantic Ocean. So we can consider this particular index in our result list. So that's the gist of this particular question. So now the point that is left with us is how do we iterate over this particular matrix and find whether the water can go to Pacific and Atlantic both. So for that, what we are going to do is we are going to first take these coordinates or these ends and try to find the water going to Pacific Ocean. As these are the corner cells, the water from here can easily go to Pacific Ocean. Next we take the next cells. So from here only these cells can contribute to sending the water to Pacific, or the water from these cells can go to Pacific Ocean. From 1 there is no way it can go to Pacific because upside is 7 and to the left is 5. Both are higher values and water cannot go over here. Similarly, moving forward, 5 is the coordinate from where the water can go, from here or you can say from here, or there are many routes. Rest, from all these places the water cannot go to Pacific Ocean. Now, what is the coordinate from where the water can go to Atlantic Ocean? So let's find out that. The corner cells, obviously they can reach the Atlantic Ocean. Moving on to the next cells, these are the cells from where the water can flow to the Atlantic Ocean. From 3 the water cannot go to Atlantic Ocean because we have 5 over here and 4 over here. And over here also there cannot be any combination from wherein the water can reach to Atlantic. Moving forward, from these cells, only 5 is the cell from where the water can reach to Atlantic. That is from here or from any other combinations that we can have. So if we take into consideration both my Pacific and Atlantic Ocean's water, so these were the cells from where the water was reaching the Pacific Ocean, and these are the cells from where the water is reaching the Atlantic Ocean. We need to find the common cells from where the water reaches to both Pacific and Atlantic, and those cells would be the ones that are present or that are marked in both these matrices. And so those are these many cells. And so this is the answer. So once we have these cells marked with us, we can easily find out what are the coordinates for these cells, and so then we can also put those coordinates in the respected format that we want our answer to be in. So that's it about how we can solve this particular question. For finding these coordinates, or for finding whether the water can reach to these points or not, we can use either BFS or DFS. BFS would be by using Q, and that would be an iterative approach, and DFS would be a recursive approach. The brute force approach over here would be that for each cell or for each coordinate, I need to apply DFS or BFS and find whether the water from here can reach to both Pacific and Atlantic. If that can happen, I can mark that or add that in my result list. But that would take a time complexity of m cross n for iterating over all the elements in my matrix, plus the highest or the worst case steps that I will be taking in order to reach to these particular positions, and that is going to give me m plus n. So my time complexity in that brute force approach would go this m cross n multiplied by m plus n, that are the maximum numbers of steps I can take for each particular cell. So I'll not be coding the brute force approach, but you can find that code on the GitHub link that is given in the description. Over here we'll see the DFS or the recursive approach for solving this problem by using two different matrices for storing what are the cells that can reach to Pacific and what are the cells from where the water can reach to Atlantic, and then merging the answers from both of them. So let's go ahead quickly and code this particular problem out. So the first and foremost thing is checking the edge case, that is the null conditions. So in these conditions we would return the result, which would be a blank list. With this I'll initialize my row and column, and I'll also take a direction that would be the directions of up, down, left and right. And now I need two matrices for storing whether a cell can give me a water that reach to Atlantic or Pacific. So I'll take Boolean matrices of the same dimension as my matrix. With this, I have the placeholder for my data in place. Over here, I'll perform my DFS, and that would fill these two matrices. After these two matrices are filled, let's first write down all the things that would lead us to result. So for adding everything into my result, I would need to iterate over this and find the coordinates wherein the value is true for both Pacific and Atlantic. If that is there, I can add that particular index in my result. And that would add the index in the result if this particular coordinate is true and this particular coordinate is true. Now I need to fill in this DFS. This was writing the result, and here I need the DFS logic. So let's first go and create the DFS function for that. So we'll have a void method. So over here, I'll have my I and j value, my original matrix, and the matrix that I am looking for. Either I am going to Pacific or either I am trying to reach the Atlantic. And with this, I'll also have a previous val because my result is going to be dependent on the previous val. So let's write that. In this method, we'll first check our boundary conditions for I and j. the next thing that we are going to do is to check whether we can go to that particular location or not. So over here, if my matrix of I or j, that is current value, is lesser than the previous value, or if the current ocean value or this particular Atlantic Ocean is already been visited or it's true, we do not need to go there and we can just return. This condition states that we are actually trying to move from inwards towards the ocean. So my matrix I of j should be higher than the value that is previously there, or value that is nearest to the ocean, so that my water can flow to that nearest value. If this is not the case, that means the water can flow. So we'll just mark this ocean of I and j as true, and then we'll call my DFS on all the 4 directions. So for that, I already have this direction array with me. So this would take care of my recursive calling. So over here, I have taken care of iterating and filling my ocean matrix. Over here, I need to write the logic for how to call this particular DFS method. So over here, let's try to write it for column first, and we are going to call the DFS on columns. So my row would remain 0 and my column would be I, and then my previous value would be integer.min value, and my ocean would be 1 is for Pacific and 1 is for Atlantic. So since this is the 0th row, that is the uppermost row, the ocean near to it is the Pacific Ocean. So I am going to say that fill this value for Pacific, and similarly will write for Atlantic. So let's copy this, and just the row would become row -1 because this is nearest to the bottom. So this would become the Atlantic Ocean. Similarly, we need to do it for rows as well, and over here my row would be I, and for this my column would be 0, and my 0th column is nearer to my Pacific Ocean, so it would go to Pacific, and my col -1 is nearer to my right end, which is the Atlantic Ocean, so that would go to Atlantic. So what we are trying to do is we are trying to start from the nearest value to the ocean, and then we are trying to fill in whether we can have all the other coordinates reach that particular point or not. So once everything over here is done, we can return the result, and that's all that we need to do. Let's try to run this, and it's giving a perfect result. Let's submit this code, and it got submitted. So the time complexity for this particular approach would become O of m into n, and the space complexity would become O of m into n, because we are taking these 2 matrices with us. So that's it for this question, guys. I hope you liked the video, and I'll see you in another one. So till then, keep learning, keep coding.